Hey, what's up guys? I'm Ben.
I'm Jed.
We're Shoestring Engineering. Today we're here to talk about catapults. What that means is,
This video will be about its history and its physics. And by definition, a catapult is basically a mechanism that shoots a projectile without the means of an explosive. And it's important that it has to be big, otherwise it will still be defined as a crossbow.
so how catapults started, it started with the first invention of the bow. The bow later developed into the crossbow, and then the crossbow was later supersized into a ballista. A ballista is a giant device with a slider, and what you would see on top of it is a bow-like structure to draw back bows, or maybe, bolts, or maybe stones. And then later the catapult was invented, or onager, as we are about to go into, which launches bigger rocks and such.
Fun fact, the first recorded use of a catapult was actually in China.
Interesting, right?
The Asians.
Alright, so let's get into the physics. The physics of catapults are they launch projectiles with kinetic energy. Now the kinetic energy is stored kinetic energy. It's not chemical-based energy like gunpowder, where gunpowder would be combustible chemical energy. Where the three types of kinetic energy that are used are gravity, torsion, and tension. The four types of catapults that use these are trebuchets, ballistas, onagers, and mangonels.
In this series, we're going to focus on the onager, and its mechanism goes like this. There is a bucket that holds the payload, and that bucket is connected to an arm. The energies pull the arm back, and upon release, it launches out the projectile.
Now, the two types of kinetic energy that the onager uses is torsion and tension. So torsion energy is created through a winding of elastic material like rope or animal sinew, most likely during the Roman era of the onager's use. And it's wrapped around in a spiral or web that is already cranked up a bit and then twisted. And once the arm is cranked back into its locking point, it's at the epitome of its elastic stretch. While the tension is more like rubber bands or bungee cords, like you would see, is just a band that's stretched back at the top of the arm or right below the payload basket. These are both relatively efficient, but we do have stronger and more elastic materials now.
Alright guys, that was the history and the physics of the catapult. And the reason why we focus on the onager is because that's the first thing we're going to build in this series.
So I'm super excited. We're going to start the project build series, where we're going to make a small scale and a large scale build. On the small scale build, it's going to be two separate designs, and a large scale will be a collaborative design.
On the small scale, we're going to fight each other with castle siege battles. And on the large scale, with a collaboration of one design, we're going to have water balloon fights.
So look forward to the rest of our videos every Friday, 4 p.m. Central Time. So please like, subscribe, and comment below.
Stay curious, guys.